Welcome back. This is section 1.2 in your book, part 2, where I'll be covering multiplying and dividing, adding and subtracting fractions. You should have read section 1.2 in your book. If you have not as of yet, please do so. Alright, multiplying and dividing fractions. Let's start with multiply. Alright, so in multiplying two fractions, we might have something like 2/3 times 5/7. The process is quite simple. We just take each numerator, the 2 and the 5, and multiply those together. And then we multiply both denominators together. 3 times 7, or 10 divided by 21. That's it. Division. Once we get multiplication down, division is quite simple also. I take 6 divided by 15, that fraction, and divide it by another fraction, say 1/3. What I do is turn it into a multiplication problem. I'm now going to say 6 divided by 15, that first number, but now I'm going to multiply. I'm not going to multiply by 1/3, I'm going to multiply by the reciprocal. In other words, I take this particular number, this fraction, and turn it upside down. The 3 in the denominator becomes a 3 in the numerator. The 1 in the numerator now becomes a 1 in the denominator. But now I have a simple multiplication. So again, multiply the numerators, divide by multiplying the denominators, or in this case, 18 over 15. This particular number can be reduced. So I'll show you how to do that on the next page. Let me pause. Okay, so I have 18 divided by 15, and I want to see if I can reduce that. So I'm going to do this by writing each number in factored form. So I'm going to factor the numerator and the denominator. So I'm going to write 18 divided by 15 and say that's the same thing as 3 times 6 divided by, this is 3 times 5. But we know multiplication, so that's the same thing as saying 3 over 3 multiplied by 6 over 5. I basically just took what we did with multiplication. If I had started with, say, this particular point and gone in reverse to multiply it, I would certainly get what's above. So there's nothing wrong mathematically with going in the opposite direction, but notice this number, 3 over 3, is the same thing as the number 1. So what I have here is 1. The number 1 times 6/5. It's not 1 and 6/5, it's 1 times that, which is equal to 6/5. So 6/5 is 18/15 reduced. Now we don't usually go through all of that. We have a shortcut in mathematics. We call it canceling. So I would say something like 18 divided by 15 is equal to 3 times 6 divided by 3 times 5. And then what I would say is, oh, these cancel. The 3 and this 3 cancel. So I'm going to cancel factors. All right, and I'm left with 6/5. All right, at this point, pause and go back to your book and try some of the concept questions. Adding and subtracting fractions are done a little bit differently. For adding and subtracting fractions, we must have the same denominator. it must be identical. Alright, so let me give you an example. If I took 1/4 and added 1/4, they have the same denominator, so it's very simple. I just take each numerator and add it. So I take 1 plus 1, and I put that over the common denominator, 4. Or in this case, 2/4, which reduces, we know, because this is the same as 2 times 1, 2 times 2. So these 2's would cancel because I'm multiplying, or because they're factors. So this becomes 1/2, which makes perfect sense, I hope. 2/4 would give you a half. Subtraction is very similar. If I had 4/5 and I want to subtract 1/5, this is equal to 4 minus 1 divided by 5, or 3/5. Notice that this sign is what shows up here in order. Right? Now if they don't have a common denominator, something like 1/4 plus 1/2, well, we need a common denominator, right? And what's normally used is the lowest common denominator. This is defined, I'll use 3 for defined, as the smallest number that each denominator divides into. In other words, it divides into it with no remainder. So in this case, 4 and 2 both divide. We don't need that e. Both divide 4. So our lowest common denominator in this case is going to be 4. I already, in this problem, 4 plus 1/2, I already have the 4 in this denominator, so I have 1/4, and I'm going to change this 1/2 to a 4. I need this 1/2, this 2, to become a 4. Well, the only way 2 can become a 4 is if I multiplied it by 2. If I multiply this by 2, I need to multiply the top also by 2, because this number, this entire number that I'm multiplying, has to equal 1. Otherwise, I've changed my problem. So now I have 1/4 plus, we're going to multiply 2 times 1 for the numerator, 2 times 2 for the denominator. And clearly, 2/4 is 1/2. So that works, and I'm left with 1 plus 2 all over 4. I'm just doing a straight addition now because I have a common denominator, or 3/4, and we know that to be true. That makes perfect sense. In the next video, part 3, we'll look at forming a common denominator using prime factorization, a very useful tool. You'll use it as you continue on in mathematics.